All right, in this tutorial, I'm going to talk about rational exponents. Rational exponents. Well, in my previous one, I talked about how roots are actually the inverse of powers. So, for example, when you have 3 squared, all right, and you want to solve for a value, or if you have x squared, I should say, x squared, you want to solve for a value 9, you would take the square root of that. So you would take x equals the inverse operation. So you'd go plus or minus the square root of 9, all right, to solve for that. And you get plus or minus 3 because you need a plus or minus because there are 2 values of x that will give you, that's can be squared to give you 9. Now, like I said before in my previous tutorial, is that when you have this right here, and you take the square root, we can also write roots as exponents. If I have this right here, the square root of 9, can actually be rewritten as 9 to the 1/2 power. Pretty cool, huh? Yes, 9 to the 1/2 power is the same thing as a square root. And truth be told, when you have a value, let's just call it x, all right, choose some sort of, we'll call it a to the n power. This is going to be the key thing, is that whenever you have a rational exponent, this numerator is known as the power of the exponent. And this right here, the denominator, is known as the root of the exponent. And the reason why it is that way is because you have to perform inverse operations in order to solve it. For example, if I wanted to figure out x squared and I want to get rid of 9, well, how do I get rid of 1/2 as an exponent? Well, if you recall from our properties of exponents, if I take this both sides to the 1/2 power, what do you do with your exponents? You multiply them. But whatever I do to one side, make sure I do to the other. All right, 1/2. And when you take the 1/2, that's like the square root. So I have to bring a plus or minus. But when you take these, you actually are multiplying. So we have 2 over 2 equals plus or minus 9 to the 1/2 power. All right. And x to the 2 over 2 is x. And this actually will turn into plus or minus the square root of 9, which equals plus or minus 3. So yes, that right there is equivalent to something like so. If we would write x to the nth power, a like that. N is the index. This is the power on the outside. And that's how we can use rational exponents. The numerator is the power, the n is the root. So let's take this out. Let's evaluate some. So what does this mean? If I have 9 to the 3/2 power, essentially this is saying I am taking, remember this is my power, this is my root. So I'm going to be taking the square root of 9 of that quantity cubed. The square root of 9 is 3. Cubed then is going to be 3 times 3 times 3, which is 27. And that's my answer. Let's try another one. If I have 3/2 to the negative 2/5 power, that's the same thing as writing 32. This is the root. This is our power. So it would be the 5th root of 32 raised to the negative 2nd power. The 5th root of 32 is 2 because 2 times 2 times 2 times 2 times 2 times 2, I believe that's 5 times, all right, equals 2. All right. And now we raise that to the negative 2nd power. A negative exponent means reciprocal. 2 squared is going to be 1 over 4. And that's what we got. And that's how you use rational exponents. Let's try one more. I'll make one up. Let's go 100 to the, let's go to, uh, 3 has power. What do we got here? Once again, this is your power. This is our root. So we're going to take, I always take the square root first. The square root of 100 cubed. Square root of 100 is 100. Or sorry, 10 that is. Cubed is going to be 1,000. And that's what we got. So what are rational exponents? Rational exponents are a way of writing roots in which you have the bottom number is your root and the top number is your power. We can do this now and perform inverse operations, okay, and also use the property exponents, all right, in solving them. So I hope this makes sense. I hope this helps you out in understanding how we can use rational exponents. Good luck and God bless in the rest of your problems.